All right, welcome to this explainer. Today, we're taking a seriously fascinating journey into the future of tech education. If you've ever wondered how the next generation of software engineers, AI developers, and system architects are actually being trained, well, you are in exactly the right place. We're going to unpack a brand new, cutting-edge computer science curriculum that is custom-built for the incredibly fast-moving tech landscape of tomorrow.
To do this right, we're going straight to the source, the official R26 course structure for the Department of Computer Science and Engineering at Vishnu Women's University in Bhimavaram. Now, this specific syllabus goes into effect for the 2026 to 2027 academic year, which means it is packed with the absolute latest industry requirements. It's a massive, multi-page beast of a document filled with credits and course codes. But don't worry, we're going to distill it down to its core essence to see exactly how a modern engineer is built from scratch.
Okay, let's dive into this. Here's our roadmap for decoding this dense syllabus. We'll be tracking a student's journey through 5 stages. 1. The foundational first year. 2. Mastering core systems. 3. Exploring AI and cloud. 4. Senior year and specialization. And finally, 5. Open electives and minors. Let's get to it.
Before we zoom into the specific classes, it really helps to think of this 4-year degree as a perfectly paced level-up system. Looking at this timeline, a student enters in Year 1 focusing purely on foundations. By Year 2, they're building core software and hardware systems. Year 3 catapults them into the frontiers of artificial intelligence and cloud networks. And Year 4, well, that's all about hyper-specialization and getting 100% ready for day 1 on the job.
So let's start at the very beginning with Section 1. The foundational first year, building the base. The first 2 semesters are intentionally perfectly balanced. They aren't just throwing students straight into complex software blind. Under basic sciences, you've got heavy, essential math and science, linear algebra, modern physics, and differential equations. But alongside that, under engineering and core, they get students coding immediately. Right out of the gate in semester 1, they're tackling C programming and digital logic design, and by semester 2, they're already deep into Python and data structures. So the crucial takeaway here is that they're building the mathematical brain while simultaneously training the programmer's hands.
Which brings us to our next phase. Section 2, Mastering Core Systems, the Architecture of Tech. Now, what's really interesting about this part is that this is Year 2, where the training wheels completely come off. Historically, sophomore year in computer science is heavily theoretical, but notice how early this curriculum introduces modern, highly demanded skills. In semester 1, full-stack development and agile practices are taught right alongside operating systems and Java. By semester 2, they're diving straight into foundations of AI and machine learning. And look at those skill courses. They're learning mobile application development using frameworks like Flutter and Rust. Those are the exact same tools top Silicon Valley startups are using today. They're learning the actual architecture of modern tech by actively building things. And that brings us to the number 2. Why 2? Well, because at the exact end of this intense second year, the syllabus requires a mandatory 2-month summer internship. The university doesn't want students waiting until after graduation to see how a real tech company operates. No way. They expect students to take the full stack and AI foundations they just learned and immediately test them out in the real world for 2 whole months.
Let's see how this builds into Section 3, Exploring AI and Cloud, the Frontier.
Answering Year 3 is a massive, massive level up. We're talking about deep learning and neural networks, quantum computing fundamentals, generative AI and LLMs, and cloud computing. 10 years ago, you'd probably only see these topics clustered in a specialized master's or PhD program. But in the R26 syllabus, these aren't just buzzwords or optional weekend tech seminars, they are rigorous, absolute core requirements for third-year undergraduate students. It is truly remarkable how fast the baseline for what a computer scientist needs to know has evolved. In this third year, the syllabus also opens up some incredible avenues for customization through professional electives. It's kind of like a giant puzzle. Under Elective I, a student can branch into reinforcement learning, dive into cybersecurity, or explore immersive design for AR and VR. By Elective 2 in the second semester, they can choose natural language processing, ethical hacking and penetration testing, or blockchain. It basically allows the student to tailor their degree precisely to the niche of the tech industry they want to dominate. And here we are again with the number 2. Following this ultra-advanced third year, there is a second mandatory 2-month summer internship. That means before they even set foot in a classroom for their senior year, these students already have 4 months of actual documented industry experience on their resumes. For sure, a real game changer.
Which leads us perfectly into Section 4, Senior Year and Specialization, Industry Readiness.
And this brilliantly illustrates how Semester 7 drops the broad academics and focuses entirely on highly marketable job skills. This isn't abstract computer science anymore. This is tech stack-specific training. In data and cloud, they offer data analytics with Power BI or AWS and Azure certification paths. In development, they're teaching microservices architecture, Django web application development, and Go programming. And under security and performance, there is literally a course on bug bounty hunting, which means they are officially teaching students how to hack companies for cash. These options perfectly bridge the gap between a university classroom and day one at a modern tech firm.
Then comes Semester 8, the grand finale. What's absolutely fascinating about the final semester of this degree is that there are essentially 0 traditional classes. Instead, the entire semester is completely dedicated to a massive 6-month major project worth a staggering 10 credits and 200 marks. This is where the student acts as a full-fledged engineer, conceptualizing, building, and delivering a complete, robust system before they can even graduate.
Finally, let's wrap up with Section 5, Open Electives and Minors, Expanding the Ecosystem.
The computer science department knows that tech touches literally everything, so there are 2 distinct paths for non-CSE majors to get involved. On one hand, we have open electives. These are individual courses like generative AI and prompt engineering or cybersecurity essentials that any student in another department can take to boost their tech literacy. On the other hand, for those who want a formal credential, there's the minor degree path. Non-CSE students can take 4 specific CSE courses, choosing from fascinating subjects like robotic process automation or basics of data science, plus 2 massive open online courses to earn an official minor in computer science. It's a fantastic way for, say, a mechanical or civil engineering student to supercharge their primary degree with serious programming chops.
So what does this all mean? Which brings us to a crucial final thought to leave you with. When you look at the sheer density of this curriculum, hands-on generative AI, quantum computing fundamentals, high-performance computing, and a combined 10 months of mandatory real-world internships and major projects built right into a single bachelor's degree, how will these highly trained graduates redefine the tech landscape of tomorrow? The engineers coming out of this R26 syllabus are going to hit the ground running faster and harder than ever before. Thank you for joining me on this explainer. I hope you found this deep dive as fascinating as I did, and keep learning.